This lesson is titled Correlation and Causality. What we'll learn to do is identify relationships between two data variables, and then we'll learn to explore the causal relationships between those two variables. To get started, correlation. So correlation exists between two variables when higher values of one variable consistently go with higher values of another. So there's a positive correlation. Or when higher values of one variable consistently go with lower values of another variable. Negative correlation. Correlation is typically seen visually when the data is graphed on a scatter plot. Okay. So different types of examples of correlation. So for instance, there's a correlation between the variables height and weight for people. That is, taller people tend to weigh more than shorter people. There's a correlation between the variables of demand for apples and the price of apples. That is, if the demand decreases, the price increases. There's a correlation between practice time and skill among piano players. That is, those who practice more tend to be more skilled. And if you were to kind of plot these, let me see if I can get a color going. Let's say for height and weight, so we have height and we have weight. It would look like this. Taller people tend to weigh more. There's a correlation between variables demand for apples and the price of apples. So if we say demand and price, low demand means higher price, lower demand or higher demand means lower price. Okay? And then skills and practice would go up like this. Okay, so plotting these with a horizontal and vertical axes is one way to determine. Usually we have different data points, but as we talked about, there's a line of best fit that goes through them, or you could see them going up together or down together or all over the place. Okay. So no correlation means that there's no apparent relationship, so your data points are all scattered. They're kind of mixed. Positive correlation, both variables tend to increase or decrease together. Negative correlation is when one variable increases while the other decreases, so that demand and price example. And then there's a strength of correlation. So the more closely two variables follow the general trend, the stronger the correlation. So this is dealing with the line of best fit. If you draw a straight line, the line of best fit that goes through all the data points, it's perfect correlation if all of those points lie on the straight line. Okay, so we have, let's say we have data points, and then we draw a straight line, and they're all on that line. Okay, same thing with negative correlation, except the line would be going down. So positive correlation. So the scatter diagram shows that the higher diamond weight generally goes with higher price. So I'm going to sketch the line of best fit kind of through here. There's a way to come up with the equation right now. I'm just eyeballing it. So the line of best fit does go in the positive direction, where the higher carat of diamond weight, the more expensive it is. Okay, so those tend to go up together. So that would be an example of positive correlation. Negative correlation. So the scatter diagram shows that higher life expectancy generally goes with lower infant mortality rates. So I'm going to try to draw a line of best fit. So looking here at Bangladesh, it has a high infant mortality rate and a lower life expectancy. Whereas over here, if we look at Israeli, Czech Republic, Greece, it has a higher life expectancy and a lower infant mortality rate. So it's important to be able to read the X and Y axes here when you're determining correlation and what's happening with your variables once you plot them. Okay, correlation does not equal causation. If you don't remember anything else I say this semester, please remember that. Just because two things are correlated doesn't necessarily mean that one caused the other. There's 3 explanations for this. Correlation could be coincidence. Maybe they just go up together, or when one goes up, the other goes down. Both variables might be directly influenced by some same underlying cause. We had talked about ice cream sales go up as sunglasses sales go up, right? But that doesn't mean that one caused the other. That is usually, it's hot outside, people are buying both. Okay, and then the third is one of the correlated variables may actually be the cause of the other. Note that even in this case, it may be one of several different causes. Okay, so further investigation is needed for those, which leads us to our confidence in causality. Okay, so there's a possible cause, and what possible cause means is that there's a few isolated incidents, and it's worth some investigation. Okay, maybe. Okay. Probable, likely. What probable means is that there's enough evidence to have strong confidence and a causality, though some other explanation might be possible. Even if that other explanation is unlikely and it exists, though, it would say probable cause. Okay, and then the third is cause beyond a reasonable doubt. All other explanations have been exhausted. There's no other explanation. The causal relationship is considered proven. Okay, so that's an overview of correlation and causality, and we'll do an example. Okay, now we'll do an example. For some reason, it wasn't on my slide, so I had to pause for a minute and make sure it came back. Okay, so one of the examples that's in the homework that I wanted to talk about. For the following pair of variables, state the units that might be used to measure each variable. Then state whether you believe that the two variables are correlated. So the correlation that we're looking at here is the age of a person and time spent on social networking sites. Okay, so it gives you a couple of options with each unit of measure. So to measure age, the unit, and then it gives degrees in Fahrenheit, minutes per website, years since birth, or hours. We typically measure age as years since birth, so that would be the correct unit there. And then to measure time, the unit, degrees in Fahrenheit, minutes per website, years since birth, or hours. So in this case, we'd measure hours. The temptation might be minutes per website because we're talking about time spent on social networking sites. But for this, we have two variables. We have the age and we have time, and each of those has a specific measurement. So you're not looking at this necessarily as a rate of change or as a slope. You're looking at what's measuring one variable versus the other variable. Okay, and then this problem, which is really what I wanted to talk about, asks you to state whether you believe that the two variables are correlated. Okay, so to do that, I would draw a picture. So when I think of this problem, I think that time spent on social networking depends on age. Okay, so age is our independent variable, and then time spent on social networking sites is our dependent variable. So with types of correlation, you have positive, negative, or no correlation. So I would draw these out visually, see what the graphs are saying, and then determine what type of correlation you think this is. So first, I'm going to start with positive correlation, and I have age and I have time on social media. If these are positively correlated, it means that one's going up as the other's going up, or one's going down as the other's going down. Okay, so what this graph says is that older people tend to use social media more. Okay, now let's go through all three possibilities, but take a look at what this is saying. It says as age increases, time spent on social media increases. Next, let's talk about negative correlation. So we have age and we have time. And if it's negative correlation, our line of best fit or our line through the data points would look like this. So what this graph is saying is that as age increases, so age getting better, time on social media decreases, meaning older people don't spend as much time on social media. And if there's no correlation, they're just all over the place. Okay? And so with these problems, use your best judgment in terms of what type of correlation you think that this is. But I think the graphs are helpful so that you can visually see what's going on with the possible cases. And in this case, I'd probably pick this one. As age increases, time spent on social media decreases. Okay, side note, my grandpa just got a cell phone. Like not a smartphone, a cell phone. Okay. Anyway, that's just one-off case that doesn't necessarily prove anything. But with this example, try to visualize what's going on. And same thing, there's other types of examples in your notes. So make sure you're reading through all the possibilities. I think visuals are really helpful. Now, if you have any questions, please feel free to reach out to me or to come to office hours.